Hello, welcome back to Piers Rocks. Today I'm going to use one ROM to read another. Before I get into today's video, I'll be at VCF Midwest in Chicago at the weekend, so if you're also going and you see me there, please do stop me and say hello. And if you want to get your own one ROM, I'll probably have a few, so just stop me and you'll get your own one ROM. So on the subject of reading ROMs, I was thinking about a comment made by Rene on my last video, the RP2350 video, where he said it'd be really interesting to see some detailed timing analysis, both of one ROM and the original ROMs in these systems, to see how they compare. So I did some thinking about how I'd actually go about achieving that, and I figured that I'd need some kind of hardware jig to actually drive the ROM under test, and then probably use an oscilloscope programmatically to measure the various timings involved. I then started thinking about what the hardware jig would need to look like to drive both one ROM and the original ROMs. And I figured that I already had the hardware that I needed in one ROM. I just needed female headers or sockets on top of the existing one ROM hardware. And then with different firmware, I could drive a ROM under test. So that's what I've got here. I've got a one ROM here, bog standard STM32 version of one ROM with a ZIF socket installed on top. And here I've got the same thing, a standard one ROM, but I've got male header pins on the bottom and a female socket on the top. Now, if you're wondering why I've got a double row of female headers on the top either side of this one ROM, that's just because it's what I had lying around. Only the middle pins here are actually connected. So let's take a look at it working. I have one ROM with a ZIF socket installed stuck to the bench in front of me, and I'm going to flash the ROM reading firmware to it now. I'm calling this One ROM Lab, and in this configuration, it's just going to try and read a ROM once and then stop, and it will output any data about the ROM to the logs. So I'll just show you flashing that and what happens when you don't have a ROM installed. So it's flashing it now, and we can see that it failed to read a ROM. In fact, it got all zeros back, so it's fairly sure there's no ROM connected. So now I'm going to install a one ROM that I have lying around on my bench. So I'll just stick it in the ZIF socket. I'll rerun the firmware, and I'm doing that just by reflashing it. And this time it's read it and has figured out that it's a VIC-20 kernel ROM. Let's try something else. So here's an RP2350. You might recognize this as the one that I've been heavily overclocking. No idea what clock speed it's running at right now. So I'll install it. I'll reflash One ROM Lab. And that's running the VIC-20 character ROM. So the last ROM was a 2364. This, as we can see, is a 2332, and it's correctly detected that it's both chip select lines are active low on this particular ROM. And then let's look at an original ROM, and I'm fairly sure this one is from 1541 disk drive. So let's take a look at it with One ROM Lab. Yeah, there we go. It's the top ROM of a 1541. So again, this is a 2364 with the usual chip select active low. So you may be thinking it's all very well to be able to read a ROM with One ROM Lab, but it's a bit lame having to plug a programmer into it to find out what's on your ROM. Well, enter Airfrog, which I've demonstrated on the channel before. This is a tiny wireless coprocessor for ARM microcontrollers. If you plug it into an ARM microcontroller like One ROM, it can access all of the RAM, flash, and peripherals on that device and not interfere with what that device is currently doing. So I previously demonstrated this integrated with one ROM and successfully decoding the one ROM firmware. I'll just demonstrate that again briefly to give you another quick introduction to Airfrog. So I plugged Airfrog into the one ROM. This is the one ROM that was serving the VIC-20 kernel ROM. And then in my browser, I can point my browser at Airfrog, and it's decoded the firmware. It knows it's running one ROM firmware. It knows it's currently serving the VIC-20 kernel ROM, and there's other details about the firmware as well in here. In fact, I can see that there's a number of different sets installed on this one ROM. So as well as the kernel ROM, which is currently serving, I've also got the basic ROM installed on it, and I've got the character ROM for the VIC-20 installed on it as well. Now let's plug Airfrog into One ROM Lab and see what happens. So I'll take it off the one ROM and plug it into One ROM Lab. Just going to give it a few seconds now to boot. It needs about 5 seconds to boot. And then I point my browser at Airfrog, and now it's successfully decoded that it's connected to a One ROM Lab instance. And it's also figured out what microcontroller it's running. We can get some more details about the firmware here, but an extra button has appeared within Airfrog that wasn't present when we were looking at One ROM. It's only present in One ROM Lab, and that's this read ROM functionality. So Airfrog understands that different types of microcontrollers have different functionality, and this has unlocked the read ROM functionality. So I can go to the read ROM page, I can hit read ROM, and this triggers One ROM Lab to actually perform a read of the ROM that's installed. So it's read that VIC-20 kernel ROM, and it's displayed the information on the screen. Of course, there's no particular advantage to using One ROM Lab to read a One ROM. If you've got an Airfrog, you can plug Airfrog directly into the One ROM directly. But if I take the One ROM out of One ROM Lab and install a stock ROM, and then hit read ROM again, then this is now, One ROM has correctly detected that it's got a 1541 top ROM installed in it. And let's just see that again with a different ROM. Not sure what ROM this is. So there we go, we've got a C64 basic ROM now installed in One ROM Lab, successfully read by One ROM Lab, and then all the information has been transmitted to us, and we've controlled One ROM Lab using Airfrog. Both Airfrog and One ROM Lab are built in Rust, while the core One ROM is built in C and assembly. And I went for Rust because it's much quicker to get something up and running on these microcontrollers once you understand and can write Rust and understand the frameworks. So I've got a little bit of code in front of you. This is the main ROM reading functionality within One ROM Lab. You can see it's very, very straightforward. It's basically just cycling through all the possible addresses, and it's looking at a 16 kilobyte address space, because if you combine all the address lines and all the CS lines on these types of ROMs, then you have a 14-bit address space, so 16 kilobyte. And then it just runs through all those addresses. It sets the address, and then it reads the address back. And then it's got some database code within it where it has the 32-bit checksum and SHA-1 digests of all the ROMs it knows about, and it tries to map the ROM it's read to those. As part of this, I had to write something that would allow Airfrog, on the one hand, to communicate with the microcontroller running in One ROM Lab, rather than just accessing the RAM and the flash and the peripherals under the covers without the MCU knowing about it. I needed to set up some kind of bi-directional communication between Airfrog and One ROM Lab, so Airfrog could instruct One ROM Lab to actually read a ROM, and then One ROM Lab would send back the information about the ROM. And I did that with this code by essentially building RAM channels on top of serial wire debug, which is the protocol used between Airfrog and One ROM Lab, to allow safe, ordered communication between two different devices sharing the same bank of RAM. And this is also relatively straightforward to use to build applications now, to have this either unidirectional or bidirectional communication between Airfrog or any other serial wire debug capable device and the ARM microcontroller. I hope you found that introduction to One ROM Lab and also a quick run through of how to use it with Airfrog and some of Airfrog's capabilities interesting and useful. As always, everything that I've shown you is open source, both the firmware and the hardware. Links down in the description. Got any questions about anything that I've shown you, please stick them down in the comments and I'll do my best to answer them. You got any suggestions for what I should get on to next, please put them down in the comments as well. I'm all ears. As I said at the beginning of the video, I should be in Chicago for VCF Midwest at the weekend. If you're also there, please do come and say hello, and if you want to pick up a One ROM or two, I should have a few available. Till the next video, rock on.